So the goal of this problem is to try to figure out how to maximize the area of this rectangular pen that you have. And one thing about the pen that you need to know is that it abuts your house. So if I were to draw a picture, it would look something like this. So in particular, you're told that you have 40 feet of fencing. And your goal then is to maximize the area of this pen. So we want to have a maximum area. Well, let's see. What is area? Area is just length times width. So let me draw that on my picture and know that the thing that I want to maximize, so we want the max of L times W. At this stage in the problem, what I want to do is just gather information. I know that I have 40 feet of fencing. I know I want a maximum area, so I'm going to use all my fencing. How much fencing do I have? Well, I have this length. This isn't fencing because I've got the house there. The wildebeest cannot go through walls. The width here and the width here. So in total, I have 2W plus L worth of fencing. In other words, I want to maximize my area, so I'm going to use all of the possible fencing that I have. So I'll set 2W plus L equal to 40. OK, so what do I have? I've got these two pieces of information. Let's see if I have enough to go on. So again, the area is equal to length times width, and I want to try to find the maximum of it. Well, the problem that I have in trying to find the maximum of this is I have an equation in two variables. Now, we happen to be taking a course which deals with only one variable. So I'd like to turn this equation of two variables into an equation of one variable. How do I do that? Well, I've got this relationship lurking in the background. Let me subtract 2W from both sides. This tells me that L is equal to 40 minus 2W. Perfect. Now I can take this area equation and think of it just in terms of the letter W. For L, I'm going to write 40 minus 2W. That's the same thing as L. Now, why is that helpful? Well, let me simplify it and see if I get any additional information. This is 40W. This is minus 2W squared. And then I realize that this guy has the shape of a parabola. Let me reorder the terms so you could clearly see that, and so that you could also clearly see something else. Written this way, we see that the leading coefficient is negative, which means that the picture, if I were to sketch it, would have this rough shape. I want to try to find the maximum of the area. So where do I need to go on this parabola? I need to look at its vertex. I'm going to ask myself what W value gives me the maximum vertex, which is another way of saying what is the W coordinate. Typically, we had been using X, but the W coordinate for the vertex. How do we find that? We use the vertex formula, which is minus B over 2A. Minus B in this case is minus 40. 2A in this case is 2 times negative 2. A is negative 2. Let me simplify this to get 40, or negative 40 over negative 4, or 10. So what did I just do? I found the W value which maximizes my area. This W value maximizes this guy, and this guy shows me the area. So what was the actual question? The question was, what is the maximum area? Well, how do I get the maximum area? Well, I know that if W is 10, that'll give me the maximum area. So all I need to do is plug it into the area formula. I could plug it in here, and that would be fine. But for me, it's always easy to just multiply one thing, then to multiply, and then add, and then multiply. So the area then is equal to 40 minus 40 minus 2 times 10, just sticking a W in, times 10. 40 minus 20 is 20, times 10 is 200 square feet. So to big picture this problem, I used the technique of drawing a picture, just writing down what I knew, developing a formula, and then seeing where that formula led me. Where did it lead me? It led me to a quadratic. And we know how to maximize quadratics, so we were able to solve the problem.